So ayun, good day. Our subject for this day is about basic calculus, and we will be tackling a lot of topics regarding basic calculus. So now let's proceed sa learning objectives natin. At the end of the lesson, students should be able to understand evaluating limits through table of values, evaluating limits through graph, limits of algebraic function, limits at infinity, lastly, continuity. And hopefully, makinig kayo because our learning facilitator or our teacher will be tackling this lesson.
Hi everyone! So I'm Elizabeth Grace S. Canlas III and I'm Teacher Tress. So for our math class today, we will all be talking about evaluating limits through table of values. So to start our discussion, as you can see here, we have our symbol of limit. So limit of f of x as x approaches c is equals to L or is L. So to fully explain this symbol and for you guys to fully understand this, I prepared a problem that we can all solve together. So right here we have limit of x squared minus 4 over x minus 2 as x approaches to 2 is blank. So as for us to solve this first, we will evaluate limits of functions using table of values. So first we will be starting to the left hand side, which means that our x values should be lower than 2 or than the original given x value there. So but first remember the x value should be closer to c, but not more than 1 unit. For example, that our x value or for example our c is equals to 4 is equals to 5. So which means that our x value should only be between 4 or 6 there. Going back to our problem, so here we have our x values. So we have 1, 1.5, 1.9, 1.99, 1.999. So you can see that it is lower than 2, but it is still close to 2 there. So to get the function value, we will only be substituting 1. We will be substituting 1 to the equation here. So we will only substitute x to the equation there. So 1 squared. So it is equals to 3. The next one is 1.5. Let's change it to 1.5. There, 3.5. So after solving this, we will be moving on to the right-hand side of our problem. There. To the right-hand side of our problem, our x value should be higher than the original x given value. It should be higher to 2. So this is our x values. We have 3, 2.5, 2.1, 2.01, and 2.001 there. So again, to get the function values, we will only substitute x to the equation. So 3 raised to 2 minus 4, 3 minus 2. There, we got 5. Next is 2.5. There. So after solving all of this, we will get these answers. So after that, I want you guys to observe our table. So let me combine them for us to fully see the difference or to fully observe our table there. So as you can see that our x values, the top row, our x values, from the right side, it's going towards the 2. From the left side, it's also going towards the 2. So observe here. Observe the function values. So after observing, we can all conclude that the limit of our function is 4. Right here. So yes, it's 4. So as you can see that from the left side, it's going towards the 4. And from our left side, yes, it's going towards the 4. From our right side, it's also going towards the 4. So we can say that our limit we can say that the limit of x squared minus 4 over x minus 2 as x approaches to 2 is equals to 4. So that's our answer. Our answer is 4. The limit is 4. So that's all for our discussion. I hope you learned something. Again, the topic that we are talking about is evaluating limits through table of values. That's all. Again, I am Teacher Tres. Thank you.
Good day, everyone. I'm Precious Arevalo, and I'm here to help to evaluate the limits through the use of table of values. We're here to investigate this linear function, which is f of x equals x plus 4 as x approaches 2, or limit of x plus 4 as x approaches 2. So, as we see here, we need to get the values of x as approaches 2 from the left. So we have 1.900, 1.9500, 1.950, 1.995, 1.999, and 1.990. So we're going to get the f of x of as x approaches 2. So using calculator, we'll start to get the first column, which is 1.900, 1.900 plus 4 equals 5.90. Next is 1.950 plus 4 equals 5.95. Next is 1.995 plus 4 equals 599. Next is 1.999 plus 4 equals 599. Put it in here. And the last will be 1.900 again 90 plus 4 equals 599. Here, we're going to put it in here. So now, as we done in our first hand, we're going to move to the right side of 2. So this is the right side of 2. We're going to put the values we have from the right of 2. So first we have 2.100, 2.050, 2.010. We have 2.005, and the last is we have 2.001. So we're going to get again the f of x. So we're going to compute it. Delete it. So 2.1, 2.1, 2.1, 2.1, 00 plus 4 equals 6.1. I'm going to put in here. And the next is 2.050, 2.050 plus 4 equals 6.05. Still the same. 2.100, 2.010 plus 4 equals 0.010. And the next is second to the last value of as x approaches from the right side is 2.005 plus 4 equals 0.05. And the last is 2.001 plus 4 equals 0.01. Now we complete the table of our values. As we saw in the table of values, the limit of f of x as f of x equals x plus 4 as x approaches 2 is 6. As you see that 5.9 almost 6, and then in the right side it's 6.001. It's already in 6. So we conclude that the limit of f of x is as x approaches 2 is 6. But there are I'm going to choose some easy way to do it, or we can do it as the limit of x plus 4 as x approaches 2. We will substitute. We're going to substitute the 2 in the parentheses, so it make it easier. So it will be 2 plus 4 equals 6, same as the outcome in our table. So that's it. So this is the end of our video. I mean, of my video, teaching how to evaluate the limit through the tables of values, and teach you some easy way to do it. So thank you.
Hello everyone, my name is Tin and welcome to our math class. So for our class today, we are going to learn how to evaluate limits using table of values. So let's start. So here we have a linear function, and we have here an example or a problem that we need to calculate the limit of f of x is equals to x plus 6 as x approaches 7. So the first thing that we need to do is, of course, to have our table of values. So here is our table of values. We are first going to calculate for the left-hand limit, and then we are going to calculate the right-hand limit. So it says here that x is less than 7. So we need to think of values, any values that are less than 7 but are still close to number 7. So in here, we can input 6.900, 6.950, 6.990, 6.995, and 6.999. So these are values that are less than 7 but are still close to number 7. And the values that we've input here, we are just going to substitute it to the x of our original equation. So if we calculate 6.900 plus 7 plus 6, we are going to have 12.900. And then if we are going to calculate 6.950 plus 6, we are going to have 12.950. So same goes to the other examples. We just need to substitute our value to the x. So here is our answer. And next one, we are going to calculate for the right-hand limit. So we have here another table of values. And it says here, x is greater than 7. So we need to think of any values that are greater than 7 but are still close to number 7. So again, we can input values like 7.100, 7.50, we can input 7.010, 7.005, and 7.001. So again, these are examples of values that are greater than 7 but are still close to 7. And the next thing that we need to do is, of course, to substitute again our values here to our x in the original equation. So if we calculate it, we would get 13.100, 13.050, 13.010, 13.005, and 13.001. So after we calculate for the left-hand limit and the right-hand limit, we need to observe our table of values. Specifically, we need to observe our values in here. Once we have observed our table of values, we can conclude that our values that we calculated are close to number 13. So therefore, we can conclude that the limit of f of x as x approaches 7 is 13. Or in symbols, we can conclude that the limit of x plus 6 as x approaches 7 is equals to 13. So that would be all for our example for evaluating limits using table of values. Thank you.
So hi. As you can see, limits are all around us. Well, in this topic, we are going to explore the word of limits as it pertains to calculus by using a graph. Because as the idiom states, a picture is worth 1,000 words. So let's start with the formal definition of a limit at a unit point. So kung makita nyo sa example dito, if we let f of x be a function and a and l be a real numbers, then we say that the limit of f of x is approaches to a. And provided that as we get sufficiently close to a from both sides without actually equaling A, we can make f of x as close to L. And formal definition can be perplexing at first, so let's make sense of this. All this definition says is that as we approach a specific finite value along the x-axis from both the left and the right sides, we want to find what the y value or the L is approaching. So, pagano makita nyo dito. And additionally, did you know that sometimes we are just interested in what's happening as we approach from only one side, either the right or the left? This is called one-sided limit. So, kung makikita nyo sa first graph na to, yung starting point niya is nag-i-start siya sa papunta sa left. So, left-sided limit siya. While dito naman sa second one, yung starting point niya is nakaharap sa pa-right. So, right-sided limit yung graph na to. And what's so cool is that our formal definition of limit is called a two-sided limit as it has to approach from both the left and the right. But what happens if we can determine what the y value is approaching? So, next page tayo. If f of x doesn't a specific finite value as x approaches from A from both directions, then we say that the limit does not exist. And let's look at an example of how to solve a limit graphically by investigating some one-sided and two-sided limit. So, sa example na to, yung value niya is tumapat sa 2. And approaching siya from left side only, kaya ayun yung value niya. While dito naman sa limited f of x, yung value niya is nakatapat sa 3 at nag-approach siya papunta sa right. And dito naman, nag-approach siya from both sides. Yung reason yan because the limit of y value gets closer to two different values as we approach so A from either side of A. We can make up of our mind as what our limit should be. Therefore, we can say that the limit does not exist. Consequently, a limit only exists if and only if the limit from the left side equals the limit from the right side. So, proceed naman tayo sa pinaka-equation natin. Ang nakalagay dito is estimate the limited x approaching to 3 using a graph. So, kung makikita nyo dito sa red line, is nag-approach siya papunta upward, while dito naman, pababa. And does not exist siya kasi wala siyang intersection dun sa dalawang graph. And the reason yan is because the left limited hand of 3 is going upward, while the right limited hand of 3 is going downward. So, hindi sila nag-connect. And for the last question, why do we care about limits? Because limits are foundational to understanding to calculus. The limit concept distinguishes calculus from all other branches of mathematics in the sense that it declares interest in how things change over time. And likewise, a limit helps us to understand the idea of closeness and approximation and is the foundation for the definitions such as continuity, differentiation, and anti-differentiation like integrals.
So, hi, it's me, Sanchez, and I'll be teaching you all about evaluating limits through graphs. So, without further ado, let's start. So, our problem for this topic is all about solving for limit 2x plus 4x when x approaches 4. So, paano nga ba natin malalaman yung answer natin through graphs? So, ang ginamit nating problem is linear function. So, let's try to graph this problem. So, ano ba ang graph ng 2x plus 4x? Slanting siya. Slanting. So, gawin na natin yung slanting. And let's not forget, yung x is nag-approach sa 4. So, tingnan lang natin. This is the 4. Dito yung nag-approach yung x. So, lagyan na natin ng straight line or limit. So, ayan na nga yung approach, which is yung x is approaching 4. So, paano natin malalaman? So, para malaman natin, let's graph yung 2x plus 4x, which is a slant. And hanapin natin kung kanino siya tumama. Okay? And titignan natin kung saan siya tumama. So, gaya nga nasabi ko, slanting yung slanting. So, let's graph the 2x plus 4x. Okay, siya. So, let me ask this question. Sa lahat ng nakalagay na number, saan siya tumama? And obviously, tumama siya. Nag-correspond siya sa 24. Yan, 24. So, the answer for this problem is 24. And if hindi pa rin kayo sigurado about it, we have some substitution. If you wanted to reject your answer, you have something na para i-reject nyo, which is the i-substitute nyo na which is 2 times 4 plus 4 times 4 is equals to 24. Diba? So, that's it for this topic, and I hope you learned something. Thank you for watching. Bye.
So hi guys, so right now I'm with Lance G, and we are going to tackle about the limits of algebraic functions. For I have an equation here. We have an equation here, and we will gonna show you how to solve it. So let's evaluate the limit. The limit of 5x cubed minus 4x squared plus x minus 8 as x approaches 2. So this is the equation we were going to solve. Let's rewrite it again. So 5x cubed minus 4x squared plus x minus 8 as x approaches 2. So this is the function. It contains 4 terms. The first term will be the 5x cubed, the second term will be 4x squared, the third term will be the x, and the fourth term will be 8. We are going to find the limit of each term of this term. In the first term and the second term, which is the 5x cubed minus 4x squared, we will apply the constant coefficient law together with the power law. While in the third term, which is x, we will apply the identity law, and in the last term, which is 8, we will apply the constant law. So the limit of 5x cubed as x approaches to 2 minus the limit of 4x squared as x approaches to 2 plus the limit of x as x approaches to 2 minus the limit of 8 as x approaches to 2. Applying the constant coefficient law, here, we have 5 times the limit of x cubed as x approaches 2 minus 4 times the limit of x squared as x approaches to 2 plus the limit of x as x approaches to 2 minus the limit of 8 as x approaches to 2. So this is 5 times. This is x approaches to 2, so the value of x will be 2. So 2 cubed minus 4, it will be the same. The value of x will be 2, so 2 squared. Plus, since the x and the x approaches 2, so the x is 2. The value of x will be 2 again, and the 8 is as x approaches 2. This is constant. The 8 is constant. Whether this is approaching 2, 3, 4, that is constant is still 8. So the 8 will be still 8. So this is the 5 times 2 cube. 5 times 2 cube. 2 cube is equal to 2 times 2 times 2. 3 times 2. There. So 2 times 2 times 2 will be 8. Minus 4 times 2 square is 2 times 2. 2 square is 2 times 2. So it's 4 plus 2 minus 8. We're just gonna rewrite the constant numbers, which is the 2 and 8. So here, 5 times 8 will be 40. The second term, which is 4 and 4, 4 times 4 will be negative 16, so 40 minus 16. And we will gonna rewrite again the two constant numbers, which is 2 minus 8. So we're going to solve this in this form. So this equals to 40 minus 16 plus 2 minus 8 is 18. So this is the final answer of this equation. But this equation can be done using direct substitution. So let's try it. By direct substitution, let's write the equation again. The limit of 5x cubed minus 4x squared plus x minus 8 as x approaches to 2 here equals, we just substitute 2 in place of x, so the x will be 2. Of the x will be 2, so 5 times 2 cubed minus 4 times 2 squared plus 2 minus 8. So here, this will be, in this problem, we will just simplify this problem. So this is equals to 5 times 8, 4 times 4 plus 2 minus 8. So 5 times 8 will be 40, 4 times 4 will be 16, so 40 minus 16 plus 2 minus 8. So this can be done, will be equals to 18. So this is the final answer of this equation. So the direct substitution is rather the shortcut method of solving this problem. So this is how you are this is how you solve the limits of algebraic function. So I hope you guys understand it. So let's proceed to Lance cheat for solving another
equation of the limits of algebraic functions.
So yeah guys, part 2 of the limit of algebraic functions. So yeah, let's start. Let's evaluate the limit of this 3x squared minus 8x plus 4. Then let's evaluate the limit of 3 squared minus 8x plus 4. Let us do it using substitution. We put 3, then replace x by 2 minus 8 and 2 plus 4. Then sa baba niya is 2 minus 2. Then 2 times 4 times 3 is 12. Yung square niya. And sa kabila rin, negative 8 times 2 is negative 16. Plus 4. 4 over 2 minus 2 is equal to 12 minus 16 plus 4 equals 0. And 2 minus 2 0. And 0 over 0 is indeterminate. Indeterminate. Wow. The direct substitution recited to 0 to 0. And back to the numerator. Set natin itong sa baba niya, factor. 3x squared minus 8x plus 4. And then split natin yung 3x and x. Then sa 4 and 2, 2 plus 2, 4. Then 9. 2 times x, that will be 2x. 3x times 2 will be 6x. The middle one will be, pagay lang dito, negative 8x. Para makuha yun, kailangan natin gawin negative tong 6 at 2. So para meron tayo negative 2, negative 6 at negative 8x. Kailangan natin gawin negative 2 to. Para maging negative 2x. Para maging negative 6x to, gagawin din natin negative 2, yun 2. So, 3x squared minus 8x minus plus 4 is equal to 3x minus 2 times x minus 2. This is the factors. Check. 3x minus 2 times x minus 2. First term minus first term. 3x squared. Tulad lang dun sa ano. Then second term. X minus negative 2. That will be negative 6x outside. Negative 2 times x. That will be negative 2x. Diba natin lalagay negative 8x. At tulad lang doon. And inside. Negative 2 times negative 2, it will be positive 4. And so the limit of 3x squared minus 8x plus 4 all over x minus 2 as x approaches 2 is equal to the limit of the factors of this 3x minus 2 times x minus 2 over x minus 2 plus x approaches 2. Then we cancel because x approaches 2, but this is not exactly 2 kaya tayo magka-cancel. Equal to na natin limit of 3x minus 2 as x approaches 2. Yun ang makikalabasan kung i-cancel natin. 3 minus 2, 3 times 2 is 6 minus 2. 6 minus 2 is 4. So the limit of the function is 4. X approaches 2. So yun lang. Thank you.
So hi guys, I'm Sophia and I'm with Jasmine. At ang topic na pag-uusapan natin is ang limits at infinity. So always remember na may rule ito, which is ang limit of function of x as x approaches positive or negative infinity is equals to L. So, ngayon, ipapakita natin kung paano mag-solve gamit ang limits at infinity. So, meron tayong equation which is ang limit of 2x plus 3 over 4 minus x. And as x approaches positive infinity. So, nagiging 8 yung infinity ko. Yaan nyo na. So, always remember na yung mga x na yan is may exponent yan as 1. So, gagawin natin is ito times natin, which is 1 over x, and over sa ilalim is ganun din, 1 over x. And then, next step is limit of, ngayon, i-ano na natin siya, pahahabain na natin siya, which is limit of 2x over x plus 3 over x, and ganun din sa ilalim, which is magiging 4 over x plus x over x. So, yung mga x is pwede na natin i-cancel yan. Ayan. And then, next thing is, isasolve lang natin ulit siya, which is, magiging 2 na lang siya. Then, ito, dalawang to is, nagiging 0 siya. Kasi parang katulad itong nasa taas na 1 over x is, nagiging 0 kasi as it approaches as positive infinity. So, 3 over x and 4 over x is will be 0 kasi malapit siya sa positive infinity. So, magiging 2 plus 0 over 0 minus 1, which is, magiging sagot is negative 2. So, ang final answer natin dito is limit of function of 2x plus 3 over 4 minus x as x approaches positive infinity is equals to negative 2. Ayan ang ating final answer. So, ayun lang. Sana may natutunan kayo sa first equation na na-compute natin. Thank you for listening. Bye!
Hi, my name is Jasmine Lady Asok, and magbibigay ako ng another example ng limits at infinity. So, ang example ko is the limit of 4x squared minus 5x plus 5 over 6x squared plus 2x minus 1 as x approaches positive infinity. So, ang unang gagawin natin is hahanapin natin yung pinakamataas na exponential form, which is yung x squared. So, i-multiply natin siya sa 1 over x squared all over 1 over x squared. So, ang mangyayari dyan is, so first, numerator muna, i-multiply natin yung 4x squared sa 1, so 4x squared over x squared minus 5x, kasi tinimes natin siya dun sa 1, and then over x squared, and so on, hanggang sa denominator. Ayan, minumultiply lang natin siya. Next, bigyan natin limit as x approaches to positive infinity. So, ganun yung kakalabasan niya. Then, isi-simplify na natin siya. So, ang mangyayari sa kanya is, yung sa numerator, 4x squared, and yung denominator niya is x squared, so ika-cancel na natin yon. And then yung sa 5, meron siyang x, and sa baba, meron siyang x squared. So, ang mangyayari lang dyan is maka-cancel yung x ng 5, and then mababawasan ng 1 yung x squared, so magiging x na lang. And as is, yung sa 5 over x squared. And then same lang din ang gagawin natin sa baba. Ika-cancel natin yung x squared, kasi para sa may x squared, and cancel yung x, and then bawasan yung sa baba ng 1, so magiging x na lang. And then as is, yung 1 over x squared. So magiging ganyan na yung itsura niya. And then, applying our theorems, all limits at infinity, as we evaluate our limit, etong mga to, ito sa dulo, will become 0. So, ang kakalabasan niya is ganito. 4 minus 0, kasi nga magiging 0 na lang tong 5 over x, and itong 5 over x squared. And then, sa denominator, 6 plus 0 din, minus 0. And then, magiging 4 over 6 na lang yung sagot. Then, kung isi-simplify pa natin, or kukunin natin yung lowest term, magiging 2 over 3 na lang. So, this is the limit of our function as x approaches positive infinity.
Ayan, so, for today, pinagawa tayo ng mga individual problem. And yung napili namin ng partner ko na problem is discontinuity. And gumawa kami ng individual solution for each problem na gagawin namin. So, let's start. First, meron tayong graph na pinagpapasihan
So, dun sa written paper na ginawa namin by partner, meron akong binigay doon na given graph kung saan makikita nyo kung ano itsura ng function na discontinuous. So, I don't know if magigets yung explanation ko kasi I'm not good at explaining. Kaya akong gawa ng solutions pero nahirapan akong mag-explain. So, sana maintindihan nyo. If ever man hindi nyo maintindihan based sa words ko, pwede dun sa kung paano ko sinulat. So, before starting, bibigay ko muna yung itsura ng function kapag continuous siya. So, nakikita nyo naman yan. Hindi talaga ako pag-explaining. Yes. Yan. So, ganyan yung itsura para malaman mo na yung function na yun ay continuous. So, first, gamit yung idea na yun, gamit dito sa pinakita ko ng continuous function, malalaman nyo kagad na yung problem ay discontinuous. So, kailangan natin siyang gawin continuous. So, first, notice nyo na yung x is equals to negative 8. Yung f of x is also equals to negative 6. So, and then yung f of negative 8 is equals to negative 3. So, ipagsasama-sama nyo lang yun kung may isang function. Pagsasama nyo sila sa isang function. Ayan. So, nakikita nyo na. So, ayan na yung isang kabuuhan niya. So, dahil doon nalalaman natin na yung isang x is also equals to negative 6. So, ang equivalent ng is ito. Ayan. So, dahil lumabas na yung ganyang function, malalaman natin na ito yung kakalabasan niya. Ay, ito. Sorry. Ayan. So, dahil nga doon sa mga napakita natin, makukonclude natin na yung f of x is discontinuous at x equals x. So, in summary, mga discontinuity ng graph na to ay x equals negative 8, which is yung una natin nahanap, x equals negative 2, and then yung x equals 6, which is yung last natin nahanap. Ayan. So, ayan yung pinaka-answer. Thank you.
Now, for this function, we are going to determine where it will be discontinuous. Now, in this problem, we are dealing with a rational expression where both numerator and denominator are continuous since both are also polynomials. Now, the only points in which the rational expression will be discontinuous is where we have division by 0. Now, we have to determine where the denominator is 0, and that's easy. And our denominator is 2x squared minus 13x minus 7. Now, we're going to factor both of them, and it will be equal to 2x plus 1 times 2x plus 1 times x plus 7. Now, we're going to get x plus 1 and transfer positive 1 to the other side, and then divide both sides by 2 so that it will be x equals negative 1/2. Since you transferred positive 1, it's going to be negative. Now, the next one is x minus 7. You're going to transfer negative 7 to the other side, which will become positive 7. Now, x equals positive 7. Now, that means the function will be discontinuous at points negative x equals negative 2 and x equals 7.